This next video illustrates some consequences of electrons needing to be described as both particles and waves. So consider the three spheres shown here. So we have three circles. They represent, for example, an orbit in an atom. You can imagine a particulate electron circling the orbit. That takes care of the particle, but what about the wave? Figure 1 illustrates what can't be allowed to happen because it wouldn't represent reality. If we go clockwise and we start at this point here, the wave begins circling the sphere, but then the problem is it meets up again in a position where it's no longer able to propagate. So you can see that the outgoing wave is moving up, but the incoming wave from the previous circle is going down. So this would, if this represented an electron, this would disappear with time, so it can't be allowed. It would lead to no atoms. So we know this is not true because we look out the window, we see atoms. Here's another scenario that can't be allowed to happen. We start here, in this position here, we start to propagate our wave. Here the wave is the electron orbiting the atom. But now you can see that both the incoming wave and the previous wave are both going up. This would lead to no atoms. It's not sustainable. So there are certain things the electron or the wave is not allowed to do. It's not allowed to do either of these things. What it must do is be continuous. If we look, finally start at this position here, we start to go round as an oscillating wave around the orbit. And then so long as I can fit in neatly with another wave, so this wave is entering the node as this wave is leaving the node, then this is okay, and we can get atoms. So there's certain ways we have to describe the wave on the orbit inside the atom. So I'll quickly erase the board and we'll look at some key ideas. We'll formalize this in a cohesive way. If we imagine that these are two nodes, then, and I have, let's say on this diagram, I have energy going this way. So I can have a wave doing this, so I can have the outgoing wave and then the returning wave. So if you imagine the dashed line is the returning wave, so it could be, for example, like this, but instead of propagating forever, I've just got it going back and forth between two nodes. So that works out because I have this continuum. I could have this. Again, so long as I hit nodes at the end, that would be allowed. This would give something like this. I could have something like this, where again, my key criterion is that I hit a node at these two positions, which would be something like this. Now, I know that energy is increasing because my wavelength's getting shorter. So recall that energy is proportional to 1 over wavelength, lambda, which is proportional to frequency nu. So as my wave gets shorter, my energy gets larger. I have more waves between the nodes, so my frequency of waves increases. So this both leads to my conclusion that energy is increasing. So I know that I can have multiples or whole integer multiples of wavelength. So here I've got, well, between these nodes, I've got a wavelength. Well, I can have a multiple of wavelengths over 2. So here, if I've got n just means number. So if n is 1, then I've got 1 half wavelength. And that's a half a wavelength. Okay. Here, I've got a whole wavelength. So n lambda over 2, where now n is equal to 2. So this would be n equals 1. Let's see, n equals 1. If n equals 1, I've got a half a wavelength. If n equals 2, and I use the formula n lambda over 2, then I've got 1 full wavelength, lambda. If I've got n equals 3, and I follow the same formula, n lambda over 2, then I've got 1.5 wavelengths, so 3 over 2 lambda, etc. You could go on, n equals 4, n lambda over 2. If n equals 4, I have 2 wavelengths, etc. These are all allowed, and importantly, it tells me an important quantum number. So this is the beginning, this n here. These are allowed energy levels. Which in chemistry are called principal quantum number. The origin of this principal quantum number is making sure that the wave nature of the electron is allowed and leads to the existence of atoms.